Welcome to Walkabout the Galaxy, the unconventional astronomy podcast where the science is universal, the opinions are personal, and the hosts charge only a nominal fee for photos and autographs. We are strange top, down, and bottom, the Astroquarks, also known as Josh Caldwell,
Jim Cooney,
Audrey Martin,
and Brendan Byrne.
Coming to you from MegaCon 2024 in Orlando, Florida. Bottom quark Brendan Byrne pops into existence like a virtual particle at the event horizon of a black hole every time we are at MegaCon. But you can always find him on the air at WMFE 90.7 and WMFV 89.3 in Central Florida. And you can find his show, Are We There Yet?, on all podcast platforms and your smart speakers, just like Walkabout the Galaxy. You can contact us anytime at WTG, not WTF, WTG at ucf.edu with questions and compliments. And today we have a listener question to start us off from Isaac. What is the three-body problem? Why is it so complicated and we can't figure out the math? The three-body problem is not just the name of the award-winning science fiction novel by Cixin Liu and the upcoming Netflix series based on that book. It's also a classic problem in classical mechanics. Jim, what is the three-body problem, and why is it a problem?
Jim about that.
I
thought I was at the wrong podcast taping for a second because I had no idea. Yeah.
So the three-body problem is just, what if I have three objects, and they are each exerting a force on each other? Classically, this is gravity. So what if I have the Earth and the Moon and the Sun, and they're all pulling on each other? Can I figure out, if I know where they are and where they're going right now, can I figure out where they are going to be later on?
And the answer is
no.
You cannot.
It turns out it's very weird. It's such a simple sounding problem. Maybe to you it's not simple. Maybe it does sound simple. With two objects, if I have just two objects both pulling on each other, we can solve fairly simply, like in a sophomore level physics class, what's going to happen to those things over time, no problem. You add in a third thing, and all of a sudden it becomes radically more complicated. And the question, from our viewer is like, why? What the heck happens when you add a third thing and all of a sudden it becomes complicated? And I don't have any great answer to that, except it's really hard, right? I mean, you have three things pulling on each other. Every second, they cause each of the other two to move around a little bit, and now they're in different places, and now I have to recalculate what all the forces are. And it turns out the system is chaotic. And if we remember from Jurassic Park and what's his face?
Jeff Goldblum.
What's his face?
What's his face? Yeah, I like Jeff Goldblum. He's great, but he's not at MegaCon 2024, I think, unfortunately, or in the audience today. But chaos is a really weird, complicated thing where if you just start your three objects in a slightly different position than you did before, the end result is totally different.
After some period of time.
After a little bit,
just to reassure everybody, the Moon and the Earth aren't going to go flying off in some unpredictable...
That we know of.
That we know of, and we do know. We do know.
Great. Yeah. Okay.
Well, today we will find out from Brendan if we are, in fact, there yet, and if not, when we're going to get there. But first, this episode of Walkabout the Galaxy is brought to you by Hohmann Transfer Orbits. For your next journey to another planet, save your fuel and maximize your payload capacity with a Hohmann Transfer Orbit, bringing you energy-efficient trajectories from Earth to your favorite destination since 1925. With a Hohmann Transfer Orbit, coast in weightlessness between your initial and final rocket burns. With a Hohmann Transfer Orbit, you can travel through interplanetary space, confident in the knowledge that your trajectory has been successfully used by Mars Insight and many other missions. Act now and get 10% off your next Hohmann Transfer Orbit to Mars, or book the launch window 26 months later for an additional 5% off. Hohmann Transfer Orbits, ready when you are, subject to planetary alignment.
Ready when you are?
We have Hohmann Transfer Orbits. This is how we're going to get to Mars, right? This is how we get there. This is how our
It's how we get to a lot of places.
This is how we get to a lot of places. And it takes time. The sponsor mentioned 26 months. Our sort of launch window intervals for getting to Mars are spaced about 26 months because Earth and Mars have to be at the right place when you launch your rocket for that orbit to get you there in the right time. And getting us to Mars, let's imagine that we are there yet, fellow Astroquarks.
All right. We're on Mars.
Let's project ourselves forward into the future. We can go to Mars. You're each going to go to Mars. Where on this big red planet do you want to go?
Brendan?
I would like to go to Jezero Crater.
Jezero Crater,
Oh, that's a
which
good
is
one.
where the
which is where
Perseverance
is
rover
right now.
is right now.
It's the only location on Mars that I can memorize. So that's where I'm going there. But it's a really, really cool spot, and scientists think that there was life there at one point. So there might be life there when I go to live on Jezero Crater. So
Okay,
there we
so
go.
you're hoping to
Yeah.
bump into some Martians.
I'm hoping to bump in some Martians, make sure there's some water, some oxygen there. Yeah.
Okay.
That'd be nice. That'd be
Audrey,
nice.
where do you want to go?
I mean, that is a good
It's a
location,
beautiful spot.
because even if you go there and you're like, this isn't great, you know that something else is going to go there to pick up the
Yeah.
samples.
Or you got somebody to talk to.
And-
Percy's there.
Percy's
Yeah.
there, yeah. I don't know. I think I want to go to Olympus Mons.
Okay.
I just
Nice.
like volcanoes are just really fun, and that's
Yeah.
the only reason I want
But
to go.
it is an extinct volcano, and it's like the size of Colorado.
It's the biggest. It's
yeah,
the biggest.
right. Jim, where are you going on Mars?
I'm hanging out with Brendan.
All right.
Aliens all the way.
Okay, you're going to Valles
I'm going
Marineris.
fossil
You're-
hunting.
You're
I'm gonna find
going
some shark's
Jezero
teeth.
Crater.
Yeah.
Okay. I'm going to what we've got up here on the screen, Valles Marineris, or maybe one of the ice caps, one of the polar
Oh,
ice
yeah,
caps,
that
to
would be
kind
fun.
of do some cross-country
Yeah.
skiing.
There you go.
Something like that.
Yeah.
That sounds really fun.
Okay, cool. Well, before we get to Mars, what's our journey to Mars? It's via the moon in some sense.
Got to go to the moon first.
We had our Artemis 1 launch about a year and a half ago, a little less than a year and a half ago.
Yeah.
What is going on? What is the status of our journey back to Mars, Brendan?
So NASA's got this very ambitious plan to put humans on the moon through the Artemis program. We saw a very successful mission in Artemis 1. There was no people on board that one. That was an empty space capsule. Well, there were some
Dummies?
There were
There were
dummies.
some
Okay.
mannequins
There
on
was some-
board.
we don't call them dummies. Or I'm not supposed to call them
They were
dummies.
smarties.
They were smarties.
People simulators.
Yes. And that went very well. The next mission is Artemis 2. That will have a crew of 4. So 3 NASA astronauts and 1 from Canada will be on board that one. But that one's going to take a little bit longer than NASA originally anticipated. It was supposed to launch at the end of this year. It's now looking towards the end of next year. That's because of a few different things happened. One, the heat shield took a little more damage than they originally anticipated on the Orion
capsule.
space capsule when it came back. Because, it hits the atmosphere pretty hard, pretty fast, creates a lot of friction.
Mm-hmm.
That heat shield there is to protect the mannequins in Artemis 1 and protect the astronauts of Artemis 2 and beyond. So they're looking into that. They also need a landing system. Right now they're working with SpaceX for the first
I'm sorry,
landing.
the landing system but that's not a factor for Artemis 2,
For
though,
Artemis
right?
2, no. But they
Okay.
still would like to have that ready
They
to
want it
go
in
to get
line.
people on Mars.
Okay,
So,
yeah.
So
Yeah.
there's a lot of things that need to come into place. Artemis 3 is that Artemis 3?
That's
There?
Artemis 3.
Artemis-
So Artemis 2 is fly around the moon, snap some pictures out the
Come back.
window.
With people.
With
about
people.
a 2-week trip or so.
Oh,
Or-
it's going to take 2 weeks?
Yeah,
yeah.
I think so. Yeah,
Whoa.
yeah.
Then Artemis 3, what's our timetable for that?
That's a little iffy. So that will be after Artemis 2.
What?
And that's about as detailed as I can get.
Oh.
We should totally reverse the order of those
Yeah,
two,
we
because
should,
Artemis
yeah.
3 is a lot more interesting.
Yeah.
So
Still need a lander for that one. SpaceX is working on that with Starship. Starship will be the lander. They still need to get that into orbit and demonstrate that they can transfer fuel back and forth before they get astronauts on the surface. Beyond that, SpaceX will have a few lander missions, and then it is open to other companies to provide another vehicle, whether it's SpaceX or another company that's going to provide more landers. Really, a lot has to go right in a very
Right.
short amount of time, and NASA's not taking any chances. So they'd rather be safe than sorry when it
Well,
comes
that's
to
good.
putting people on the moon. So
That's
Right.
definitely good.
So Artemis 3, you're not even going to hazard a date for that one.
I am not. No.
You can be wrong.
So
It's okay.
the architecture and then there is nominally an Artemis 4 and even an
and
Artemis
during this
5.
entire process, they will put a mini space station in a very intricate orbit around the moon that will be used as a staging ground for moon missions, but also Mars missions, which we can talk about a little bit later. But all of that is happening at the same time. So there's a lot going on to get humans onto the moon, and that's only what 250,000 miles from
Right.
home.
Only.
Only.
That's a
Only.
3-day trip instead of like an 8-month
Exactly,
trip.
exactly.
So it's a very different story.
Yeah.
Didn't we do this in 1969?
We did do it in 1969.
Why is it so hard to get back?
Well, that's a very good question, Jim. It's because we're going to someplace completely different. So the moon missions of the 1960s and early 70s were to the equatorial region of the moon. The Artemis missions want to go to the South Pole region of the moon, which is far more difficult to physically get there, and it's also far harsher than the equatorial regions. It's colder. There's we believe ice is trapped under the surface,
which is
and it's
one
very
of the
dark.
reasons why we want to go
One of the
there.
reasons we want to go there as well is to be able to trap or to collect that trapped water ice and use it for fuel and life support as well.
Right. I mean, we think about like water frequently. When you hear about like finding water, we talk about it all the time. Oh, they found some water on the moon. Oh, they found some water on Mars. It's like enough already. Okay, we know there's some water on both of these locations. Why is that so important? It's not because, the astronauts forgot to bring a bottle of water like I forgot to bring to MegaCon here. It's because, as you said, water is actually burnt rocket fuel that with some electricity you can unburn.
Mm-hmm.
Decompose it into hydrogen and oxygen. The hydrogen is rocket fuel. Mm-hmm. You burn it with oxygen. You reproduce that water and you get rocket thrust. Is this a reason why the moon is potentially part of the trip back to Mars?
It is, and it's to establish a solar system gas station, essentially, right? So you're able to make this fuel, make these supplies that you need, because it's very difficult it's inexpensive to get mass into orbit and off this planet. So if you can make your fuel on the way to Mars, then that is a really cost-saving and mass-saving feature of your architecture. So that's exactly why NASA's interested in water on the moon.
Yeah, right. I guess the moon is way easier to get off than the Earth is.
Yes, yeah. You all know the intricacies and the math behind that,
well,
but yes, simply it is.
So on the moon, you weigh about 1/6 what you weigh here. That means all the fuel weighs about 1/6, and the rocket that you're taking weighs 1/6, and the mass of, say, a Falcon 9, a SpaceX rocket, or the SLS, NASA's big vehicle, or the SpaceX new heavy rocket, all these rockets, more than 90% of the mass on the launch pad is fuel.
Mm-hmm.
Only a tiny little amount. In fact, if the Earth's gravity were only a little bit more than it is, it would not be possible physically to get off into space using chemical rockets,
Really?
using chemical propulsion.
I didn't know that.
That's
There's
terrifying.
a limit to the
I know.
specific impulse that you can get from chemical reactions, and so that's why
Wow.
93% or whatever the number is of these rockets is fuel. If you turn up the gravity of the Earth a little bit, that 93% has to go up, right?
Right.
So we're pretty close to 100%. Once it gets to 100%, then it's like there's no more thing getting up into space
There's
anymore.
always an existential crisis on the show. Now I'm thinking of being trapped on this planet.
I know,
that sounds
that's what I'm
terrifying.
thinking.
Yeah,
too.
but it's okay. The mass of the planet
Okay.
is changing very, very slowly, Brendan.
And there's
So
no way that we can turn up the gravity that we know
it is
of,
being
right?
turned up
Okay,
by
just slowly.
meteoroids impacting us on a regular basis, but that's happening very slowly, so you don't need to worry about that.
Okay.
Man,
And
I
on the
thought I got
moon,
off
that
the hook.
93% number is going to be much, much
Okay,
smaller.
okay.
So that's why it's a great fueling station, as you mentioned. Yeah, this Gateway miniature lunar space station, let's talk about how does that work in the whole Artemis program. So you mentioned it's in a funny orbit.
Yes, what is it called?
It's called halo orbit.
Yes. I can never pronounce it.
It's a very highly inclined orbit. So if we think about the moon orbiting the Earth parallel to the floor, if we want to, Gateway will be orbiting perpendicular to that, parallel to a wall, on a very elongated egg-shaped orbit.
Right, which allows astronauts to get to that South Pole region, right? That's what makes it much easier. But the Gateway is going to have a habitat on it. It'll have a power and propulsion system on it. They'll be able to send cargo to it. So essentially, Orion, the spacecraft that launched on Artemis 1 and will be taking our astronauts to the moon, will dock with the Gateway, and then the lunar landing system will also dock with it as well. So they'll use it as a transfer system, and they'll spend a few days living in Gateway before the astronauts head down to the moon. So almost like the Apollo days where you had the command capsule would orbit the moon and then the lunar lander would go down. You will
Right.
just have a permanent base that will be in lunar orbit.
Is it about the size of the ISS?
It's much smaller. It is
Much
very
smaller.
small. It is
Oh,
very
no.
small.
Hopefully bigger than the Apollo thing, because that was really
bigger
crazy.
than
Yeah,
the
that was
Apollo
very
thing, but
small.
it is much smaller. So we think of the International Space Station as this massive, almost like a football field size piece of equipment in low Earth orbit. This will be much smaller. You only would want to spend a few days in the Gateway. You wouldn't want to live there for very long.
I definitely wouldn't.
Yeah.
I don't think it has showers.
No showers. The
Yeah.
toilet is actually going to be in the capsule, so you would use the toilet in the Orion capsule.
Okay.
I do not know
like
details
an
of the
outhouse.
toilet on the lander yet,
Right.
but yeah.
Yeah. And so getting back to Jim's question about, like, didn't we do this 50 years ago? What's the problem? Why, we were launching Apollo missions every 3 months
Yeah.
in the late 60s, early 70s. What's gone wrong? So one thing you mentioned was going to the South Pole, where there's ice buried in the dirt, so part of a bigger architecture. But also in the 60s, we were like in this mad dash race.
It's all
We could
politics,
Go
right?
plant the flag. Is there any of that going on now? And is there also like the issue of we want to have a little bit more of a sustainable infrastructure?
There is, and we recently heard from congressional leaders that there is a concern that we are in another space race with another country, and that's
Ooh.
China.
Oh.
China has a very ambitious plan to land humans on the moon. They're landing robotic landers on the moon. They've got a space station that has a crew on it that's consistently crewed now, and congressional leaders grilled NASA and asked them, is China going to be a new adversary? So there is this kind of geopolitical space race happening once again, and there are concerns from our politicians that China will misuse the moon. So that's why they want to get there first.
Why does it have to be a race, though?
That's how you get money. That's
Yeah.
how you get
Alright.
congressional money.
Okay,
Yeah, that's
fair
how
enough.
you get funding.
Yeah. And they are also focusing on the South Polar region for
They
the
are,
same reasons
yes,
that
yeah.
NASA is. So let's talk a little bit about some of those steps that need to happen that you alluded to with the lander. So Gateway doesn't exist yet, so that's being built. In principle, there will be multiple modules, including contributions from the European Space Agency. But it's like we haven't built it. We don't know how is that launching with a SpaceX vehicle, presumably.
I believe so, yeah. So the
Falcon.
launch vehicles aren't ready, the actual hardware isn't ready, and the lander isn't ready.
And
So
so the first lander, the lander
Awesome.
planned for Artemis 3 and Artemis 4, is the SpaceX Starship.
that's correct, yeah.
And we've had two really exciting.
And those blew up, right?
On purpose,
Yes.
right? On
Got
purpose.
Got
yeah.
it. Great.
Yeah.
Okay, so we're
we call that a rapid unscheduled disassembly,
Yes.
actually, Audrey.
Oh, I'm so sorry.
Yeah.
Okay.
But those were some interesting flight tests, and I believe Integrated Flight Test 3 is coming up
Soon. We don't know when, but
imminently,
soon. Yeah.
perhaps this month.
Yeah, and yeah, that needs to launch. It needs to get to orbit. And Starship it's this really cool, massive looking rocket.
It is the most powerful rocket ever
It is
launched.
the
in
most
fact.
powerful rocket ever launched. And once it gets into orbit, in order to get it to the moon, it will need to be refueled multiple times with other starships. So not only is it's a brand new spacecraft that they're building, but this is new technology and having to refuel it into orbit up to like 12 or 13 different times that they will actually have to mate and transfer cryogenic fuel and then send
Which
it off
has never
to the moon.
been
Which is
done.
never been done at this scale before.
Right.
It's been done in small scale testing. So there are still a lot of technical challenges ahead, but the way SpaceX iterates its design by blowing things up and moving very, very fast has worked out very, very well for them. They are a solid provider of launch capabilities and launching humans to the International Space Station.
Right.
They're actually bringing home a crew tonight that's going to be landing somewhere off the coast of Florida. The AX-3 mission will be coming home in a SpaceX Dragon
And
capsule
this is
tonight.
the
that's
private
cool.
crewed mission
This
to
is
the
a private
International
mission.
Space Station.
So while there are technical challenges, this company is up to the challenge, but there are still a lot of technical challenges to get this off the ground, pardon the pun, and on to the moon.
Right. So the number of successful test flights of the Super Heavy with the Starship lander vehicle that need to occur before Artemis 3 gets a green light. Do you know that number?
Not off the top of my head, but
in the dozens.
Yeah, it's a lot
of flights.
Yeah, it's a lot.
So even if SpaceX is launching a successful Super Heavy with a Starship once a month, we've got at least a couple of years before that system is certified for landing people on the moon.
And that's for Artemis 3.
Artemis 3. Artemis 2 won't depend on
Artemis
that.
2 can go before all that happens.
So the kind of 2-year timeline for Artemis 2 doesn't rely on any of this.
No.
But then Artemis 3, 4, 5,
Right.
6.
And NASA doesn't want to get too far away from that first launch, Artemis 2 and Artemis 3 launch, so they're staggering.
So one thing that'll be very exciting to see, so obviously the Artemis 2 mission will be very exciting. We'll see astronauts going beyond low Earth orbit for the first time in 50 years.
You guys are
More
scaring
than
me.
50
Like,
years.
Are we going to get to Mars before I die?
Well, that's a
doesn't
good
sound like
question.
I'm freaking out.
What do you think?
I don't think so.
No.
Well, how long are you planning
What do you
on
think,
living?
Brendan?
I don't
My diet
think,
says
I
not
don't
long.
think we will see a Mars mission in our lifetime, and that's unfortunate.
Speak for yourself. I
think
plan
you
on
will?
living a very, very, very long time.
We'll see moon missions, absolutely. But a Mars mission is very difficult. On top of all of this, you mentioned it, or our sponsor mentioned this. A moon mission, Artemis 2 will last about 2 weeks. How long does it take to get to Mars on a good day? Maybe 8 months?
Right.
Oof.
And that's just there.
Just to get there.
And then to come back would be another 8 months if everything lines up right. So you're spending time on the Martian surface.
Right.
You're en route for 16 months. We've only put humans in space for a little over a year at one time, and they've come back, and it's been really hard on the body. So we still have a lot of stuff to figure out about not only our technology, but how we as a species
Can
actually
survive
can
that.
survive being in space for that long, in deep space for that long.
Well, I'm going to be very interested. It'll be very cool to see the Starship land on the surface of the moon because it'll do uncrewed,
First,
robotic landing test mission before we
Yeah.
put people on board. That'll still be a very dramatic,
Oh,
interesting, because this
absolutely.
is a big rocket. The scale of this dwarfs by far the Apollo lunar modules that landed on the surface of the moon.
And there are plans for it to launch out of Kennedy Space Center. They're building the pad at Kennedy Space Center for these missions, so we
Nice.
will be able to
We'll have
see
front row
it right
seats.
down the street. Yeah,
Very exciting.
Yeah.
You mentioned, of course, the months that it takes to get to Mars. The home and transfer orbit requires that the planets are in the correct relative orientation. So you get there, the astronauts want to come home. The planets have to be in the right orientation for that to work. Turns out what that means is either you make a very, very short stay and immediately come home, or you're stuck there for a while, which means you've got to have some infrastructure to survive.
I didn't realize. I kind of just thought, oh, once they get there, it doesn't really.
You
I
can
don't know.
just dial in your 4-week plan, 10-week
yeah,
plan,
exactly.
or whatever.
Yeah,
No.
and then it's
kind
fine.
of like
come on,
3
come on
weeks or
home
1
and-
year, kind
Yeah.
of.
And that's
Okay.
that's difficult. And then what if something goes wrong mid-trip?
Yeah, we've
while
all
you're
seen
on
The
the
Martian.
surface. We've all seen this. And then there's a lot of risk in going to Mars. And you spend all of that time getting there, all of those resources. Do you want to spend just 3 weeks on the surface? Probably not. That mission is probably going to be a very, very long mission when it first gets there,
Right.
just to take advantage of the time and the resources that it took to get there. And plus, you've got to make all of your resources while you're there, right? Very similar to what's happening, or the plan to happen on the moon. You got to do that on the Martian surface. So,
So we have sent a lot of things to Mars. One of the things we do on Walkabout the Galaxy is a trivia. So to our audience, do not blurt out the answer if you know the answer, because we'll come to the answers at the end of the show. But I'm going to let my fellow co-hosts here hear our trivia questions and think about it while we talk about what our current Mars missions and upcoming Mars missions without humans are. And our trivia has to do with Mars missions. How many launched missions that were intended to go to Mars, so I'm allowing for failed missions here, how many launched missions intending to go to Mars have there been, including flybys, landers, and orbiters?
ooh,
When did the first spacecraft arrive at Mars? What and when was the first successful soft landing on Mars?
Oh,
what
boy.
and when was the first fully successful Mars landing, which was a different thing than the
So
first
a soft
successful
landing and fully successful
Yeah,
are two
and
separate
how many
things.
successful Mars rovers have there been? Okay, so we'll come back to those in a few minutes after we get an update on the current state of Mars exploration. So, the big mission that people are talking about with Mars now is not humans to Mars, it's Mars sample return.
Right. Yeah, and we have Perseverance, which is a rover. So there's one. I'm counting.
Okay,
That's on the surface.
That was a successful landing, right? We
I
can
think
count
it
that,
was
yeah.
successful. I consider it successful. That's in Jezero Crater right now, and it's picking up samples and caching them for another mission to come and then grab those samples and bring them back to
so
Earth.
here's what those look like. So these are sort of little test tubes
Little poops, I like to think of them as.
of Mars rock and dirt that the rover has gone around, has drilled, and it's put them in these little canisters.
Yeah.
So there are two different ways it's storing those. It's storing some of them in its belly, in the trunk of the rover.
Right. Yeah. So it's keeping some in its belly, and then is going to dump them at a agreed upon location once all of the infrastructure to get to Mars to pick them up is set up. But it's also dumping them.
Mm-hmm.
So it's got, I think that the ones that we're seeing here, which have been dropped on the surface, are like the backup plan.
Yeah.
If all goes well, it'll have 20 or 30 of these tubes in its trunk, and some future mission that you alluded to with another rover and or a helicopter, or who knows what, maybe a tractor trailer or a glider or something, is going to show up to Perseverance and take the whole package out of the trunk and take it over to another vehicle, put it in that vehicle.
Then launch that vehicle.
Then that vehicle launches.
And then there has to be something orbiting Mars to catch it, and then something else to go from there all the way back to Earth.
Can I ask what may be a silly question?
Yeah.
Why do you care about, you scientists, care about getting samples back from Mars? Can't we just
Jim cares the
analyze
most
it
about this.
on the surface of Mars? Why do we have to get our hands on it?
Going to throw Jim under the bus.
Aliens!
Oh,
No,
yeah.
I mean, it's easy. Obviously, Mars is close enough that we can stare at it, we can look at it, we can get light from it, we can analyze all that business, but all of that information that we get pales in comparison to what you get if you actually have a piece. We do actually have a handful of chunks, right, that have come
That's true,
as
Martian meteorites.
Meteorites,
Yeah.
right.
But
there
the
are
problem with Martian meteorites is we don't know exactly where on the Martian surface they came from. So we can use all of our spectrometers and cameras and be like, oh, I think it came from Olympus Mons, or I think it came from Gale Crater, but we don't know for sure. So a really great thing about this is we know exactly where these samples came from. We know the exact geologic context in which they were dug up, and we know when. We know everything about it.
And they haven't been changed. Like, meteorites come through the Earth's atmosphere
Yeah.
and then sit on the ground for years, decades, century,
knows?
whatever.
And
So-
because of aliens, right? Because
Well-
we think that there
So
were...
that's why you want the
Precisely.
rocks from
Yeah.
Mars.
Every time I try and say that we're going to find sweet aliens, these guys crush my dreams and say water didn't really exist on Mars for long enough to make aliens and stuff. But I still believe, Brendan, in
I do
aliens.
too.
Yeah.
I do too,
So,
Jim.
Are you're an alien? You're a Martian optimist?
I'm a Martian optimist.
Okay.
Yeah.
But I remember asking a scientist who's working on the Perseverance rover that very same question. Why do you want these rocks back? And she's an astrobiologist and says, well, we're looking for signs of life on Mars. And if we're going to make that claim, we need to have the evidence. The extraordinary
yeah,
claims call
absolutely.
for extraordinary evidence. So
Yeah.
we have to physically have these things in our hand, use our technology here on Earth that may not even be developed yet.
Right.
That may be a future technology advancement that will be able to prove or disprove the fact that there were aliens or life at one point on Mars. So
And-
Yeah, and there's really great instruments on the rovers that are, I mean, it's incredible, the technology, but there's nothing like having a lab and being able to really do a whole bunch with these samples.
Yeah, I mean, so you mentioned that we've got some free Martian samples in the form of Martian meteorites, but there's all sorts of questions and asterisks that go along with those. And of course, 30 years ago or something, when I was in grad school, there was a lot of excitement about one of those Martian meteorites
Oh,
that
yeah.
people claimed had evidence of life on Mars. Not so much, it
No.
turns out with closer examination. But we also have all the other meteorites or samples of asteroids. That did not stop us from spending a lot of our space investment to go to an asteroid and scoop up really just a handful of material off the surface of the asteroid Bennu, which the OSIRIS-REx mission returned to Earth just a few months ago. That material is unique and precious, as those Mars sample return material would be as well. But as we're showing here, the schematic for the Mars sample return. So first, the canisters that are pooped out on the surface of Mars, those are the backups in case Perseverance ends up getting rolls down a ditch, falls off the road,
Right.
turns upside down.
Attacked by Martian aliens.
It gets attacked by
Right.
Martian
Yeah.
aliens, and
Yeah.
we can't get to it for some reason.
Yeah.
It's dropping a backup repository of these test tubes on the surface that a future Ingenuity helicopter could go to and pick up. But the number of missions just to get a briefcase worth of samples back from Mars is kind of astonishing. Perseverance is doing, okay, I've collected some samples. Then nominally there's an Earth return orbiter mission that gets launched. Then there's 2 more missions that need to be launched to get something down to the surface. They can get something up to Martian orbit that then can transfer something to bring it back to the Earth. There's we don't send stuff to Mars every day. This is
No.
multiple launches just to get a briefcase.
And we've never sent anything back from Mars.
Right, exactly. And
Right.
I think it's really cool too, because Perseverance is a NASA mission, but NASA is asking other space agencies around the world for help, for collaboration. And so ESA, the European Space Agency, has, I think, agreed to help. And I think now JAXA might be involved in this in some
Japanese
way.
Space Agency.
The Japanese Space Agency. And there's more and more space agencies that are kind of popping up around the world, so maybe they'll help out too. So
And
it
it's-
might be like a nice global healing kind of moment.
Yes.
It's also because it's really expensive.
Well, that too, but also
It's
healing.
like tens of billions
and
of dollars.
Friendship.
Yeah. Yeah, but it's expensive. We need
Yeah,
to share
okay.
the cost.
Well, I mean,
That
but I
too.
think what Audrey is pointing out correctly is that there are some ancillary benefits,
Yes.
non-scientific benefits, to everybody coming
Yeah.
together to do something that is too challenging for any
Yeah.
one entity, even NASA, to do on their own. We're talking about when will we walk on Mars. There have been a couple of projects for sending people to Mars permanently. There was this Mars One, was
Mars
that what
One,
it was
yeah,
called?
no.
Actually, did you know one of my graduate students was one of the 100 finalists
Really?
for the Mars One
Really?
project? Yeah. So that obviously isn't happening, but that idea was people will go to Mars. We've been talking about how difficult it is to get back from Mars. Well, why not just eliminate that part of the problem? Okay, so you send them to Mars, keep resupplying them with food and water and new movies or whatever to keep them entertained, live on Mars. But I don't know, do you want to move to Mars,
No.
Jim?
No.
Okay.
No.
No.
You can't go fishing there.
No. You leave everybody forever. Your kids, your wife.
You can't
your
go
what-
breathing there.
Right,
but
yeah,
why do you not
exactly.
want to go to Mars?
What?
You said you leave everybody forever, and I said, yeah, but why do you
right.
not want to go to
Right,
Mars?
right. I am antisocial, and that would be kind of cool. But no.
Yeah, it
it's
just seems kind of
claustrophobic.
There's not a
morbid
lot to
in some
do.
way.
The dining options are very limited.
Yeah.
Yeah.
I don't think Uber goes there.
They don't
Not
have.
yet.
Yeah.
Yeah,
So,
not yet.
so you want to get back. That's a huge problem. We talked about how difficult it is to get off the Earth. It's easier to get off the Moon. Mars is in between. On Mars, you weigh about 3/8 what you weigh on the Earth, so it's not as bad a situation, but it is challenging. Also, there's an atmosphere, there's sort of just enough atmosphere to get you into trouble.
Mm-hmm.
Yeah.
You got to be careful about it with the friction coming in,
Yeah.
but it's so thin you can't really use it to stop yourself like we do
Well, you
landing
can
on
use
Earth.
parachutes, which is
but
nice.
not only.
Well, yeah, okay.
Yeah.
So maybe
Parachute
before we
so
do
far.
the trivia answers, we should just say, what year do you think we'll land on Mars with people?
Okay.
Go.
2064.
Oh my God, I'm definitely gonna be dead by then. 2053.
2050.
That's very optimistic.
Thank
yeah,
you.
I'm the cynical journalist. I'll say 2080.
2080.
Yeah.
Okay.
I think I could survive that long.
Yeah.
We may have some people in the audience who will make it to 2080. I'll definitely be around in 2080
Yeah.
for
Yeah.
sure. I know
All
you
right.
will too, Brendan. Jim, not so much.
Not so much.
Yeah.
He'll be on Mars.
Okay. So let's talk about the Martian trivia. How many launched missions that were intended to go to Mars have there been, including flybys, landers, and orbiters? That means it launched, but maybe it got there, maybe it didn't. What's the number? Brendan.
I'm going to say something around 13.
13. Audrey.
Whoa. I think like closer to 40.
Whoa, okay.
I was gonna go that as well. I'm gonna go with 36.
Audrey wins it is actually, 50. 50 missions.
I was going to say 50 first, but then I was like, oh, I said 2050.
Yeah, no.
That's
So
a lot of missions.
that is a
That's
lot of missions. And the next
All right.
question is, getting back to like how long we've been sending things to Mars, when did the first spacecraft arrive at Mars?
78.
1978.
1970.
1970, says Audrey.
1959.
1959, says the cosmologist, just to put that
I had no
in
idea.
perspective there. 1965.
Okay. So
I
Audrey,
wasn't that
you're
far
closest,
off.
yeah.
Oh, yes.
Yeah, but there's like these key elements of like, when did we first actually really
Yes.
get into space? Here's the Mariner 4 mission, which
Yeah.
flew by Mars on July 15th, 1965.
Sweet.
So that's how we've managed to have 50 attempted launches to Mars.
We started
We've been
early.
doing it
Yeah.
for a while, right?
Man, I am terrible at this game.
That's fine.
So bad.
What and when was the first successful soft landing on Mars? So something landed on Mars, not by crashing or impacting the
Was that?
surface.
I'm going to go with Sojourner. Was that Sojourner?
Sojourner?
Yeah.
Is that what you said?
Yeah. Is that the wrong planet?
That's the correct planet.
Okay.
Do you want to give me a year for that one?
Soft landed in 83.
83. Spoken like a true youngster.
I think it was a lander.
It is a lander because that's what the
'cause
question
it's
is.
landing. I don't know.
Okay.
But not that. I don't know.
Time's up.
76.
76.
It is 1971. The Soviet Mars 3 lander survived for 110 seconds on the surface.
Nice.
It
All
transmitted for 20 seconds. It was transmitting its first frame, which I'm showing those pixels, which may or may not be something. They may be static. It's not known if the camera was pointing face down at the ground, if it tipped on its nose like the recent Japanese lunar lander. But fun fact, is that recently citizen scientist Vitaly Egorov analyzed a gajillion images from Martian orbiters and believes he's found
They
the
found
debris from the Mars
That's
3
awesome.
lander from December of 1971.
Nice.
When was the first fully successful Mars landing? We're going to skip Audrey unless she comes up with her answer as soon as Brendan's done with his.
I'm going to say 83 again.
83. Brendan's not learning from his previous
No.
mistakes.
73.
73 for Jim Cooney.
80.
Come on, you guys. None of you remember the Viking landers, 1976.
76.
Face on Mars.
Viking 1 and Viking 2 landers. Those were the first fully successful
See,
landers
we're all
on
bad at
Mars.
this. It's okay.
Yeah.
I'm glad we're all
And-
bad at
Yeah.
it. Yeah.
Our final Walkabout trivia is, how many successful Mars rovers have there been?
5.
6.
7.
5, 6, 7. Somebody else says 5.
5.
Actually, 6. Here we are. There is a Chinese rover that operated for a year, and 5 NASA rovers, including Sojourner, which Brendan mentioned earlier, and Perseverance and Curiosity, which are still operational. And then, of course, the intrepid twin rovers of Spirit and Opportunity. So Perseverance there in the upper left, is currently going around creating those little cache samples of material for a future hoped-for Mars sample return where Jim will finally get to meet his Martian alien.
And it's got a microphone on it, so it's taking cool sounds of the planet.
There is
does?
air. It's about 1/100th the density of what we've got here in the room, but it is enough to transmit wind and have dust devils and all sorts of cool atmospheric phenomenon.
Sweet.
Well, while it may have felt like trying to get a celebrity autograph at MegaCon, it was just another episode of Walkabout the Galaxy. Give us 5 stars, and we'll give you the universe and an autograph.
Be sure to follow us on Facebook and Instagram. Subscribe to our YouTube channel, Walkabout the Galaxy. Catch up on old episodes wherever you get your podcasts.
Our theme music was composed by Richard Jerusik. Production assistance is provided by Logan Basinger. Thanks to our listeners right here in Orlando and around the world.
And tune into my podcast, Are We There Yet? On 90.7 FM, or the same place you get this podcast, Walkabout the Galaxy.
Thanks also to the folks at MegaCon and Chuck Lindsay of the Creator Stage. Stay safe. I'm Josh Caldwell.
I'm Jim Cooney.
I'm Audrey Martin.
And I'm Brendan Byrne.
We're the AstroQuarks, signing off until the next episode of Walkabout the Galaxy.